Happy day, students. In our last class, we talked about the resolution, power of the telescope and microscope. And along with that, we studied resolution limit also. Okay, the resolution limit of the telescope I have written on the board as well. We studied that in the last class, resolution limit is 1.22 lambda by t. And this resolution limit is also represented by theta. Which is this theta? This theta. Okay, if this I consider as the axis of the lens, the objective lens of the telescope, and this is how the light is coming. Light is coming from very far. So angle made by that light with this axis of this lens is also known as resolution limit. And resolution limit is 1.22 lambda by t. So this is the way we calculate resolution limit of telescope. Okay, that's all as far as the diffraction is concerned. Now we are moving on to another topic, which is polarization. Now this is also a property which is shown by wave nature of light. Okay, before this we studied interference as well as diffraction, and those two establish that the light travels in the waveform. Okay, but from these two we could not find out whether the light is transverse wave or longitudinal wave. That kind of thing is proved by polarization. So before going into polarization, we will little bit discuss about nature of light. Okay. So first thing is how light we are calling as electromagnetic wave. How is electromagnetic? Okay. So first thing is we know that light doesn't require any medium for propagation. It can travel even through vacuum. Okay. And this electric field and magnetic field also does not require any medium for propagation. They can also travel through the vacuum. So it was assumed that if we consider that on the sun there are many charges, okay, many nuclei, okay, charges are there, and if those charges are in motion, as we have studied, when the charge is in motion it produces electric field as well as magnetic field. So if we can assume that the charge is oscillating, suppose Q charge is there and it's oscillating. So what will happen? Since this is an accelerating charge, it will produce electric field and magnetic field both. Okay, and how the electric field will be produced? Since the motion of the charge is there, if I consider electric field along the direction of motion of charge, and since the charge is coming towards this point and going away from this point, so we can say that electric field is varying. Okay, and the motion of the charge can be considered as current. Okay, and we all have studied that when the current is moving in this direction, then it will produce a magnetic field on this direction towards the board, into the board. Okay, so electric field here is along y-axis, and you can say that magnetic field is being produced along z-axis by a charge which is oscillating. So since the charge is oscillating along y-axis, we know that because of oscillation along y-axis, the energy can be propagated along x-axis. Similar to what we have studied in string. If we are going to oscillate our hand like this, then energy moves along x-axis. Same way, if the charge is going to oscillate along y-axis, the energy will be propagated along x-axis. In which form? In the form of electric field and in the form of magnetic field. Okay, and electric field is oscillating along y-axis and magnetic field is oscillating along z-axis, and the light is moving along x. Okay, so light we are saying is actually electromagnetic wave. Alright, but in this particular case, we are not going to discuss much about the magnetic field. We are going to discuss mostly about electric field, even though the energy is carried by magnetic form also and electric form also. Okay, but total energy right now we are going to give it to the electric field only. So let us discuss it. If suppose that there is a charge which is going to oscillate along y-axis. Okay, but we know that there cannot be a single charge alone over there. There will be many charges. So one charge is moving along y-axis, another charge will be moving like this, along this oscillating, along this oscillation, along this oscillation. And if I consider that the light is moving along x-axis. Okay, So how will be the electric field oscillating? I have already told you that electric field is oscillating in the same direction as that of the charge. So it's along y-axis also, it's along this axis also, it's along this axis also, it's along this axis also. Along all the axes, the electric field is moving in this direction. Okay. If I consider that at any point over here, the net amplitude of electric field is E naught and it's in this direction. Okay, and if I assume this angle to be theta, and I can say that in this direction, the component of amplitude of electric field is E naught cos theta, and in this direction it will become E naught sin theta. Okay, alright, so E naught is the resultant. Along x-axis component is E naught cos theta, along y-axis component is E naught sin theta. And what is E naught square? You can say E naught square is Ex square plus Ey square. Ex is E naught cos theta, Ey is E naught sin theta. Okay, if I talk about intensity, now if E naught is actually the amplitude, then intensity is what? Intensity is actually E naught square. So intensity, the net intensity we can write as Ix plus Iy. Okay, so Ix is what in this one? Actually Ex square. Ex square, what is E naught square cos square theta. Okay, same way Iy is what? Ey square, that is E naught square sin square theta. Okay, now is this theta constant all the time? No, cannot be constant. Why? Because when this particle is oscillating, the electric field magnitude is changing. Okay, so because of that reason, this theta cannot be constant, it is varying. So if this particle which is producing electric field is oscillating by making an angle or making a phase 0 to 2 pi, this angle also changes from 0 to 2 pi. So what will be the average value of this intensity? Ix average will be what? For average, we have to integrate this. E naught square cos square theta d. From where to where? 0 to 2 pi. Okay, the average value of cos square theta or sin square theta for 0 to 2 pi, its value is half. Its value is half. You can directly write over here. This is E naught square by 2. Okay, now E naught square by 2 actually means what? I by 2. Same way, if I am going to find average intensity along y direction, I by average, that will be written as E naught square sin square theta d theta, and integration from 0 to 2 pi. Again, sin square theta's average value is also 1 by 2 when you are going to integrate from 0 to 2 pi. So here also you can write E naught square by 2, which is actually I by 2. So Iy is I by 2 and Ix is I by 2. That means energy is propagating along x-axis also and energy is propagating along y-axis also. Now I suppose that I am going to make this light which is going in this direction. Other than this, what we have done, just check that how actually is the energy propagating. So if I say two particles over here, suppose one particle is oscillating like this and another particle is oscillating like this along z. Okay, one is like this, another one is along this. So how will the wave propagate? So along y-axis it will go like this. Okay, and along z, how will it go? Along z we can make something like this. Okay, this is along z. So there is an oscillation happening along y-axis also and z-axis also, and entire yz plane also. Okay, well the wave is moving along x-axis. Now polarization basically means what? Restricting the oscillation of the wave or restricting the oscillation of electric field in just one plane. That is called polarization. Okay, here right now what is happening, because there are infinite particles which are oscillating at one place and the wave is moving along x-axis, but the oscillations are happening along y and z plane entirely. Okay, that light is called unpolarized light. What is this over here? This is unpolarized. So what we will do? We will polarize it. Now what is polarization means? Polarization means restricting the oscillation of light or electricity in one direction or one plane Okay, that is called polarization. That means what this polarizer is going to do? It is going to allow the oscillation, suppose along y-axis. So only y-axis oscillation will be moving and the z-axis oscillation it is going to absorb. Okay, right now we found that Iy was something like I0 by 2 and Ix was I0 by 2. So I am taking over here, let's assume it is Iz. Okay, in two directions it is moving, Iy and Iz. So this polarizer will allow only one direction to move ahead. That is the process called polarization. Okay, so immediately the intensity will decrease to half of the actual intensity. Are you able to understand? This is called polarization. Now how polarization is achieved? That we have to check now. Okay, so first method through which the polarization can be achieved is through reflection. Okay, through reflection. Polarization through reflection. Okay, and it is based on Brewster's law. Brewster's law. What Brewster's law says? If suppose light is incident, unpolarized light. Now how unpolarized light is shown, that also you have to check. Unpolarized light is shown like this, that it is oscillating in this way also and this way also. Okay, this will be given. That means oscillation along y also and along z also. So see, I will show you here. This is the incident light and it is unpolarized. This is unpolarized. So unpolarized means I have to show it is oscillating, electric field is oscillating along two directions. So this is how it is. Okay, so Brewster's law says, if suppose the reflected light is going in this direction, okay, and a refracted light which is going in this direction. If refracted and reflected light are perpendicular to each other, then reflected light is plane polarized. Reflected light is plane polarized. That means you can say it is polarized. Here electric field will be oscillating in one direction only, whereas refracted one will have both. Okay. So at what conditions this can be achieved? When reflected and refracted ray are perpendicular to each other. Now suppose that this medium here is having coefficient of refractive index mu. This is angle of incidence. This is angle of reflection, which is also equal to I according to the laws of reflection. Now we'll try to find out the expression for this one. Let's check that what we can do. So we know that whenever we are talking about refraction, we always write as mu equal to sin I by sin R. Now here this sin R is this one. This is R. Okay, here I am taking this as R dash. Alright, now you can check this one. This R 90 plus this R dash, which is equal to I can say this total angle is 180 degrees. Okay, so I plus 90 plus R equal to 180 degrees. Right? So R equal to what? R is 90 minus I. So this R value I am going to keep over here. So what is going to come? Mu equal to sin I by sin of 90 minus I. So sin of 90 minus I means cos I. So it will become sin I by cos I. Okay. So sin I by cos I is tan I. So here we are going to get tan I mu equal to tan I. So I equal to what? Tan inverse mu. So here we are getting the condition of Brewster's law. If angle of incidence is tan inverse of coefficient of refractive index of the medium, then reflected light is plane polarized light. Okay, that's it for now.